This is an A-level and IB chemistry video. It's on group 7, group 17, the halogens, and we'll be looking at trends in properties, specifically trends in electronegativity and the boiling points. Again, if you've been watching me, you'll know that I like to kind of blurt some summaries at the beginning before we get into the more in-depth content. So we'll just start by saying that the boiling points increase down the group. Bear that in mind. Whereas the electronegativity decreases down the group. And we'll talk about why now. But yeah, I'm going to grab my highlighter and remind myself. So let's start by reminding ourselves what the term electronegativity means, because otherwise we won't understand why electronegativity decreases down the group. So in case you're asked to define this, electronegativity is the power of an atom to attract a pair of electrons towards itself in a covalent bond. So if we consider that definition, the power of an atom to attract a pair of electrons towards itself in a covalent bond, what's going to be doing that attracting is obviously going to be the positively charged nucleus. So ideally speaking, you want a small atom, don't you? So that attraction force is stronger. So to really spell that out, electronegativity decreases down the group because there is an increasing distance between the nucleus and bonding pair of electrons, and that's due to increased shielding. Remember, these are the group 7 or group 17 elements, so we're starting at the top with fluorine, chlorine, bromine, iodine and astatine. According to what we've just said then, fluorine is the most electronegative, astatine is the least electronegative. And remember, this goes some way to explain why fluorine can be involved in hydrogen bonding, because remember, hydrogen bonds form between hydrogen and highly electronegative elements, which you have to learn, remember, are fluorine, nitrogen and oxygen. And that's the only time hydrogen bonds will form. What about if we consider the boiling points now? So the boiling points of group 7 increase down the group. Don't just rote learn these things, guys. Just remember to use facts that you're probably already aware of. So the fact that fluorine and chlorine are both gases, bromine is a liquid. Remember, we're talking at room temperature here. Iodine and astatine are both solids. So that tells us automatically that the boiling point increases down the group. But why is that? Well, it's because the number of electrons, and therefore the number of electron shells, increases down the group. Fundamentally, that means that the halogen molecules, because remember, they're all diatomic molecules, this means that the molecules are larger. And then if we consider intermolecular forces, the intermolecular forces that are important here are the van der Waals forces. So with the molecules being larger, there's a larger electron cloud to distort. So we're going to say that there's more van der Waals forces. Which require more energy to overcome them. The boiling points of the halogens increase down group 7 because the covalent bond strengths increase. No, remember, with the boiling points, you're breaking intermolecular forces. Covalent bonds occur within the molecules, so that's not the reason. Bond polarities increase. Again, that's false. You've got two of the same atom, haven't you? The surface area of the molecules increases. Remember, that's true because as you descend that group, the atoms have more shells for electrons. The electronegativities increase. No, that's false. They decrease down the group. Do make sure you go through the other options if you're not entirely sure, just proving why they're all wrong, and that will help you zoom in on the right answer even if you're not 100% sure. Explain why chlorine has a lower boiling point than bromine. So chlorine is a smaller molecule with fewer shells of electrons, so fewer van der Waals forces between molecules. So less energy is needed to overcome them.